Hello everyone, this is Tanay and welcome to my channel. In today's video, we're going to solve this integral problem and it looks hard. It is not hard, it is known as the Gaussian integral and it's very easy. So let us start, okay? So now, first we're going to do is, we're going to name this as I, okay? So in I is equals to integration of this, okay? So I'll tell you at last where this is used for and then I'll connect it to a previous video of mine. Now, we will square this, okay? We get I square is equals to this, okay? Now, we'll write this as this. We get, like we write x squared as x into x, we can write this in as this into this, okay? Now, what we're going to do is change this from x to y. You might be asking, how can we do that? It is perfectly valid in mathematics because we are creating a dummy variable known as y, and this y is as a placeholder. Wait a minute, it's glitching. I hope it's fine. Okay, yeah. So y is used as a wait a minute. Y is used as a placeholder instead of x, so that we can perform the integration in dx dy both. Then we can change it into polar coordinates, which is r d theta, r dr d theta. Okay. Now what we'll do? We change this to okay. I hope you can see. Yes. Okay. Now what we'll do is we'll just combine them. We'll do normal multiplication where we get this as a okay. Now what is this? We have the same base, so the powers add up, so we get minus x square minus y square. So we can write it as this. Okay, now what? Now we'll use the polar coordinates. If you don't know what is a polar coordinate, it is nothing but a new type of coordinate system where instead of using x and y, which is straight lines which are perpendicular to each other, we use concentric circles like this, and like that. So here we use complex numbers mostly, so we can call it as e I theta is equals to cos theta plus I sin theta. We can use that formula. So mostly what we do is we take a line, okay. For example, this is a vector a vector or r vector, let's say r vector, and we take this component which is r cos theta and this component which is r sin theta. So use that r cos theta, r sin theta as the two new coordinate systems instead of x and y. So x is equals to r cos theta because this is theta and then this is r cos theta, and y is r sin theta. I'll just write it here. Okay. Now we can put the value here. Okay. But what will we get here? Okay, what will we get here? What is minus x square minus y square? We can get minus common and brackets we have x square plus y square. What is x square? X r cos theta. R square cos square theta. What is y? Y r square sin square theta. Add them. We get minus r square sin square theta plus r square cos square theta. We take r square common minus r square sin square theta plus cos square theta. What is that? 1. We get e to the power minus r square. So the final expression we get from here is this. Okay. Here I will do the transformation now only before changing. Okay. Here I have changed the limits of the variables and I tell you how did I do that. E to the power minus r square as I have told you r dr d theta. Now what is this? When we change from dx dy to dr d theta, we add that r dr d theta for a conversion, you can say when we are converting from this system, coordinate system to this coordinate system, we convert them also, obviously. And there we use this. I'll tell you how do we convert them. Yeah, so we get this as an expression, okay? And why do we change the limits? Because when we change the variables, unless they are not, unless they are same, we won't change the limits. But here they are not same. We change the limits. So the theta term is from 0 to 2 pi, and r term is from 0 to infinity, as the radius cannot be negative. Easy. And then we let me just erase this. Let me just tell you how did I get the dr d theta, r dr d theta. So what do we have? Dx dy. Okay. Now when we take this thing, okay, and differentiate them. So let us do partial differentiation of x with r and with theta. What do we get? R, we get cos theta minus r sin theta. My bad. Wait. This is wrong. It is minus cos theta plus r sin theta. Okay. Wait, cos theta is minus sin theta. My bad. So it's r. Wait. Okay, let me just write it again. It is r cos theta minus sin theta. Okay. So r sin theta is r cos theta. The r comes out and sin theta becomes cos theta, and r cos theta is minus sin theta. Okay. Okay. Now you do the same thing with y. Okay. Dx by dy by dr plus dy by d theta is equals to r. Here we'll take r sin theta, right? Wait, I messed up here. It is r cos theta, so we take from respect to r, we get cos theta only, and then when we take respect to this, we get minus r sin theta. Okay, yeah, so cos theta minus r sin theta. Okay, here we get the same thing, but reverse. Okay, we get sin theta because dy by dr, this becomes the constant, and we take the constant and integrate that first, and then differentiate them. I'm taking integration. Differentiate that this first to cos theta, which is wait, am I messing up? Let me just check once. R cos theta. So you take r goes out. Okay, wait. What is the differentiation of r cos theta? So constant term cos theta is integration. So differentiation. I'm saying integration. Minus sin theta. So it's minus sin theta. Okay, and then we take this. We take cos theta constant and r like that. So wait. Okay, yeah, I understood why I'm messing up. The constant remains same. We don't differentiate that. So it's cos theta. So r becomes constant. Constant comes out. Yes, sin theta comes out. And then here sin theta's differentiation is cos theta. Cos theta here. And we have r. It is positive. Okay. And then we have minus r sin theta here because cos theta is minus sin theta. Okay, this is what we get now. Now what? Now we use matrices. Okay. So now what matrices we'll use? We'll take them in matrices, okay? Cos theta, r cos theta, sin theta, r sin theta. And then we'll take the determinant of it. Okay? So cos theta minus r sin theta. You can skip this part if you don't want the derivation of how it is r dr d theta. Okay? Now what is the determinant of this? This minus this. We have r cos square theta minus r sin square theta. Now what we get from here? We get absolutely nothing. No, we get stuff here. We get stuff from here, okay? Don't say it's nothing. I think we have to do something here. Let me just check once. Oh. Let me just write this here. Okay. What am I what I'm missing here. We have this equation. Now it is not going anywhere, is it? We have dx dy, we have r dr d theta, and then we have the matrices. We can add them up, then what we get? If I add them up, we get r plus 1 cos theta minus r plus 1 sin theta. We get r plus 1 common, and we get r plus 1 sin theta plus cos theta, which is nothing. Yes, trash. Minus theta, minus sin theta, okay? Okay, just check one again, and you're getting nothing. R cos square theta minus. My bad. Yes, this is what I messed up. So r cos square theta minus of r square theta, which is plus sin square theta, and then we take this form and we get r. Oh, that's nice. We got r. So this is the extra term we're getting here. Okay, so when you convert dx dy into dr d theta, we get this r term from here, and that is why we have r dr d theta. I think this is nice, isn't it? Okay, now let me just erase this all up, and then we'll continue with our derivation. So I've cleaned this up, and that matrix which I have made, that r cos theta, r minus r sin theta, cos theta, sin theta, whatever matrix I made that time, that was known as a Jacobian matrix. So what is Jacobian matrix? We have a matrix where we have del x by del r, del x by del theta, del y by del r, del y by del theta. Okay, just copy this format. Okay, this is a matrix. Del x by del r, del y by del r, my bad. Del x by del theta, del y by del r, del y by del theta. This is known as the Jacobian, and then this is the term we get here, r. Okay, so we can say dx dy is equals to Jacobian dr d theta, and the Jacobian is 1. Then we have linear transformation, but it is not 1, it is r, so it is not it is not like 1-to-1 transformation. Now let's continue with our derivation. We have been diving into this topic for a while right now. Okay, now what we'll do is we'll separate them. Okay, we'll pull this 0 to 2 pi, which is for theta, and 0 to infinity, which is for r, differently. So what do you get? 0 to infinity e to the power minus r square r dr and into integration of 0 to 2 pi d theta. Okay, not bad. Okay, not bad. Now what we'll do is we'll find this now. What is this? What is this term? It is theta, and then we get this is 2 pi. This integration is 2 pi. Now we should find what is this integration equals to. Let us call this a, and let us call this b. B we know it is 2 pi. A we don't know. So let us find a. Okay. So I hope we have taken the screenshot. Let us find a now. Let me erase this. We just need this equation. Okay. Now what we'll do? We'll use minus r square. We use substitution method. Basically, we use substitution method where we say here r square is equals to t. Differentiate both sides, we get 2r dr is equals to dt. Let us put it now. We get 0 to infinity. I think it's approaching somewhere. This half goes here. We can just say that. Therefore, r dr, which we have here, is dt by 2. This goes outside. This is all basic stuff. Then we have e to the power minus t. R dr is dt. Now we use integration. Integration of this is what? What is integration of e to the power x? Okay, we say x not minus x. X basically. It is itself. There are many means on it. Okay, so this is half e to the power minus t, and there's a minus symbol because we take differentiation of the power, which is minus 1. Minus 1. Okay, so this minus comes here, and then this is what we get. But we forgot the limits. Look at the limits. Oh, okay, what is this now? Interesting. Now what we have now. Okay, let us just put this here. We get minus half into minus e to the power t. This is the same thing, okay? Minus e to the power t. But here t is infinity. Here t is 0. Now, you don't know what is this term. You know this is 1. Okay, because e to the power, anything to the power 0 is 1. So this is 1. Now what is this term? Okay, let's imagine this. What is e? 2.718. What is infinity? Infinity. Now what is something to the power infinity? If you say in casual sense. Infinity, right? So this becomes infinity. And what is 1 by infinity? 0. So we just put this as 0. So we get is minus half. And this is 0, minus 1 is minus 1. So it is half. So you got a is half. And b is 2 pi. Okay? Remember, right? So now we'll do the last part of this. Okay? Let me just use it. So let me do this with that pen, okay? We had this equation, we solved it, and we got this. With black pen, let me do it. I square is equals to a into b, okay? Okay, and then we had I square is equals to a, we got was half, b we got was 2 pi. We cancel this out. And there you go, my friend. This is the integration of the Gaussian integral. Therefore, this integral from minus infinity to plus infinity is, I hope you understood this part, okay? This is the easiest part. Square root of pi. I'll write it again for you. Yeah. AB, I square is half into 2 pi. 2 cancel out. This is so satisfying, I can do it for ages. Now, as I told you in the starting, I'll tell you the physical meaning or the meaning of this thing. Remember, I told you in my quantum mechanics video that the Bond's rule, Bond's statistical interpretation tells this. Okay? And we have this dx is equals to 1. Okay? Now, wait. Yes, this. Now, this is a Bond's statistical interpretation. We don't need it now, I'm telling you. What was the rule? That area under the curve of the entire system, or entire part where the particle can go, the probability is always 1. So, for example, if it is here, okay, so if the particle's probability here is 40% highest, here it will be 10%. And then here is 10 to the power minus 3%. And when we add them up, okay, what we will do when we add continuous functions? Integration. This is what we get. 1. But there's something known as Gaussian integral, which has the same bell curve like pattern, and it says that bell curve, the area under that bell curve, is root pi. Magnificent, isn't it? So this is for today's video where we have covered about the Gaussian integral, how do we change from normal or linear coordinates to polar coordinates, how what is Jacobian coordinates, I mean, yeah, Jacobian transformation, then what is this actually used for, and yeah, how do we derive it. I hope you have loved my video, and if you want more such videos, please comment down the ideas. For now, thank you, goodbye.